So this is the first of the advanced units as part of the GCSE, which is all looking at right-angled triangles. And the first thing we're going to look at is Pythagoras' theorem. And Pythagoras' theorem connects the sides of a right-angled triangle. And what Pythagoras' theorem says is that the area of the biggest square that you could draw on a right-angled triangle, which is on this longest side, which is called the hypotenuse, is equal to the area of the other two squares together. So this square, b squared, added to this square, c squared, would give me this area, a squared. And we can see that that's right. This takes up 9 squares, this takes up 1 square, and if we counted all of these, we would see that it took up 10 squares. You can check that if you'd like to do so. So my 9 plus 1 gives me my 10. So the way we do this, if we're asked to solve a triangle, which means find one of the missing sides, is that the first thing we do is we're going to square all the sides. We're then going to think, are we looking for the longest side, in which case we're going to need to add the two areas together? Or if we're looking for one of the shorter sides, so let's say we were looking for this one, we would take b squared away from a squared. So if we're looking for the longest side, we're going to need to add. If we're looking for one of the shorter sides, we need to subtract. And then the last thing we need to do is to square root. So we're going to have a go at 3 examples. So let's look at this first one here. I've got 3, 8 and x. So the first thing I'm going to think about is this the longest side or is this one of the shorter sides? Well, I can spot that this is the hypotenuse. I can see that it's the longest side, partly just by judging it, but also because it's the other side of the triangle away from the right angle. So that's where I'm always going to find my hypotenuse. So I'm just going to put a little hype there just to remind myself that that's the hypotenuse. So let's start by squaring the sides. And I, as a reminder to myself, just draw, they're not perfect squares, and I just draw them freehand, and I'm going to write 8 squared, so 8 times 8. 8 times 8 is 64. 3 squared is equal to 9. And I know that those two added together, 64 plus 9, must give me this area here. So 64 plus 9 equals 73. So I know that x is going to be, I need to do my last step, which is square root. X is the square root of 73, and I'm going to need to reach for my calculator here, and let's just do that. Now on the calculator, square root 73 equals, and I'm going to give my answer to 1 decimal place. Gives me 8.5. Just check that next decimal. I'm not rounding it up because that's only a 4, so it's just 8.5 centimetres. And we'll give our answers to 1 decimal place unless it tells me otherwise. Okay, let's have a look at the next one. So here, I'm trying to find this side here. I should be able to see that this is one of the shorter sides, that 10 is my longest side. So it's going to be a subtraction problem. So let's square the sides. 10 squared equals 100. 10 times 10. 4 squared equals 16. So this is going to be 100 take away 16, which is 84. So x is the square root of 84. And again, reaching my calculator, square root of 84 gives me an answer of 9 point. Be careful here because I've got a 6 after my 1. I'm going to round it up. It's going to go to 9.2 centimetres. Okay, the last question is a bit more difficult. It's asking us whether or not it's right-angled. If it is right-angled, then the hypotenuse would have to be the longest side, so this would have to be the longest side. So if it's right-angled, then Pythagoras' theorem works. So let's see whether or not Pythagoras' theorem works. 15 squared equals 225. 36 squared equals, well, I'm going to reach my calculator here because I don't know that off the top of my head. 36 squared gives me 1,296. I'm going to add them together. So adding the two together gives me 1,521. Let's check what 39 squared is. $1,521. So, what can we determine? These two squares added together is the same as this square up here. Therefore, it is right-angled, because Pythagoras' theorem works. Okay, pause the video now while you just take down those three worked examples, and when you're ready, press unpause and you'll be able to have a go at some questions yourself. Okay, so for the first 6 questions here, you're being asked to find the missing side. Sorry, I didn't draw the right-angled symbol on here. Just be careful as to whether it's an addition problem, you're finding the longest side, or a subtraction problem, you're finding one of the two shorter sides. For questions 7, 8 and 9, you're trying to work out whether or not Pythagoras' theorem works. If it does, then it's right-angled. If it doesn't, then it's not right-angled. Pause the video now while you write down the questions, and then when you're ready, unpause the video and you can see the solutions. Good luck. Okay, so let's take a quick look at the solutions here. So for the first one, it's an addition problem because you're trying to find the longest side. So you do 3 squared, which is 9, plus 6 squared, which is 36, add them together and square root them. Should have given you an answer of 6.7 meters. 2 and 3 are also addition problems. In both cases, you're trying to find the longer side, so you should have got 26 meters and 11.2 meters. Just mark those off as correct if you've got those. For question 4, you're finding one of the shorter sides. 11 is the hypotenuse, it's the longest, so it's going to be a subtraction problem. 11 squared, take away 7 squared, should have given you 8.5 meters, 13.1 meters, and question 6 was 60 meters. Question 7, 8 and 9, you're trying to check whether or not it's right-angled. In this case, you've got 16 squared plus 12 squared is 400. The hypotenuse squared is also 400, so it's right-angled. For question 8, it's not right-angled because it's 169 versus 196. And for the last one, it's right-angled. The sum of these two squares gave you 8281. The sum of the hypotenuse also gave you 8281. Okay, give yourself a mark out of 9 for those, please. And if you need any more assistance on the topic of Pythagoras, please take a look at Hegarty clips number 498 and 499. Well done.